All right, everyone, thanks for joining us. We're going to be talking about vectors today. So first off, definition of a vector. If you read the book says vector is a directed line segment. A directed line segment. Okay, so it kind of looks like a ray instead of a segment, but it's neither one of those. What it is actually, well, sort of a segment, and it has a direction, so that's why they call it a directed line segment. That's why it has the arrow. You would want to know which direction this is facing and how long it is. And how this is useful, we use it for velocity, we use it for force, we use it for all kinds of things. So let's say two people run a race, Mark and Tom. We might put Vm for Mark's velocity. Now, Tom is not as fast. Okay. And how we'd represent that is Tom would have a shorter vector. And just by looking at it, then you'd know, okay, Tom is clearly not going to be going as fast. And we use this for forces, for velocities and stuff like that, because in physics it's helpful to have a diagram. So if he was 50, and if this, let's say Tom was, I didn't measure this, but let's say Tom was half the speed, then he'll be 25. Okay, and they're obviously not running, they're driving in this race. But basically that's how it's going, and the length is proportionate to the magnet. The length is the magnitude, and that tells you how much force or how much energy is directed in that segment. So how is this useful? Other ways, if you're flying a plane directly north, but the wind happens to be pushing at you with a little bit of force this way, your plane velocity would be headed forward, the wind velocity would be going that way. Your plane would not go straight. It would actually end up going that way. And so that's how we add up two vectors. We stack them together. What we call this is the tail. I cannot spell tail. There we go, tail. And this is the head, or the arrow part is the head, the front of it, tail and head. And then you put tail to head. And from there, you figure out the resultant vector, that third vector. That's the final direction. And when you look at this, why this is useful, this is just triangles. Now in this case it's a right angle, but it doesn't have to be. But we have enough laws now that when we put all these vectors together, all we're dealing with is triangles. And how's it a directed line segment? Well, you might talk about the angle here or the angle inside, and then it's a direction and a length. That's all it is. So really it's just two parts of a triangle. That's all that's going on here. Okay, so let's get over to the homework questions and stuff like that. Some of the questions are going to be very much like that. You just draw them. You don't actually have a number or anything like that. You just draw the direction they're going. For some of the other problems, you will actually have numbers, and that's useful to have on the XY axis. So what we have there is then, they're going to give you coordinates, sort of like, let's say you had one point down here, and it's going over to this point over here. Okay, so if we're going to find the component vector for this, what we need to do is know the coordinates. This is at 1 and then down 3. So 1, negative 3. This is at 1, 2, 3, 4, 5, 6, 7, and down 1. Okay. So the formula in the book looks complicated, and here's how it goes. You take Q1 minus P1 and Q2 minus P2. All right. Well, what are all those? This is just your first point, so we call it P1, P2, and then Q1, Q2. So all this is saying is just subtract the x's. So 7 minus 1, subtract the y's. Now be careful here. Negative 1 minus a negative 3. So I have 6, and negative 1 minus a negative 3 is 2. Okay, how is this useful? This is the component vector, first of all. So when the homework asks you to do it, you got that part done. But what the hell is that? What did we just find? Okay, this is where it's really useful. If you want to go from here to here, you would go across 1, 2, 3, 4, 5, 6, and up 1, 2. So your x component is 6, and your y component is 2. That's what this is. That's all it's telling you. Okay, so over 6 and up 2. And you're like, well, isn't that kind of like the same numbers we'd use for slope? Exactly. It's exactly slope, but just written in a different way. We use brackets like this so you know that it's referring to a vector as opposed to just a point. Okay. But the other reason this is useful is if you were going to graph this thing, what you could do is start at 0, 0, and I should have made this a little more straight. I apologize. 1, 2, 3, 4, 5, 6, and up 2. That is your component vector. Okay. What do I mean? This has the same length. These have the same length and the same direction. By starting at 0, 0, we only have to remember one set of coordinates instead of both. We say, okay, hey computer, when you're dealing with this, just convert it over to this. You just have to memorize one set of coordinates. All right, and that's useful because it tells us the direction is 6, the height is 2, and your formula for magnitude, what it actually is, it's the it's your v1 and v2 squared. And what's that? That's what these points are. That's your v1, v2. Oops. Yeah, let's move this over here. Sorry about that. So we draw magnitude bars like this so they don't look like absolute value. And we go v1 squared plus v2 squared, so that's 6 squared plus 2 squared. Like, what the hell is this? This is just a squared plus b squared. If we call this a, b, and c, that's just the Pythagorean theorem. So this thing is nothing more than just the Pythagorean theorem. Okay, so I know it's a lot of new notation, but really this is just the same numbers we use as slope. These are the same numbers used for Pythagorean theorem. So what you get is 36 plus 4, or square root of 40. That's okay, but let's go ahead and take it down one step further. Let's break it into 4 and 10. And again, we're using 4 and 10, not 8 and 5, but 4 because we can square root it and make it 2. 10 we can't do. And there's your magnitude. Whoops. Okay, so at the heart of it all, it's just triangles, is just x's and y's and hypotenuses. Okay, and the only thing that's going to get a little bit more tricky is the diagrams, and then we'll have, instead of it always being a right angle, we might have a non-right angle, like 38 degrees or something like that. But that's where sines and cosines comes in. So we can handle all this. Vectors are not that bad. Thanks for watching, and hopefully this helps.